Welcome to this WiseOwl Excel VBA tutorial. In this video we'll talk about how to use ADO commands and parameters. We'll start with a quick reminder of how to use an ADO command to return a record set object. Then we'll move straight on to parameterizing the SQL statement that populates the command text of the command object. We'll look at how we can map values to those parameters. If you choose to let your users pass values into the parameters, we'll talk briefly about how you can validate your user input. We'll then move on and look at how you can create and append parameter objects to a command object. We'll have a quick comparison of ADO and SQL Server data types. And then to finish the video, we'll have a couple of examples of reusing parameters in a couple of different types of loops. So let's get started. Okay, to get started in this one, you will need to check a few things. First of all, that you have access to an instance of SQL Server. If you haven't already installed one, you can learn how to do that in a couple of video tutorials we have set up, which explain how to install a free developer edition of either SQL Server 2017 or SQL Server 2016. I'm going to be using the latest Microsoft OLEDB driver for SQL Server to connect to my instance of SQL Server, so you'll need to download and install that separately. If you're not sure either why or how, then we do have a video which explains that as well, which is the first part of this little mini-series on connecting to SQL Server using ADO. You might also need to grab hold of a copy of the script which creates the movies database. I've provided a link in the video description so that you can download this folder, and inside there is just a simple script for creating the WiseOwl movies database. It's the standard one that we've used for the other videos in the series, so if you've already done this in previous videos, you don't need to do it again. If you haven't installed it yet, then you will need to launch SQL Server Management Studio and then open up that script file by pointing to wherever you extracted the file to, and then double clicking to open the file. And then when it's opened, you can simply execute the script to create the movies database. It shouldn't take too long, it's not a very big database. Eventually we'll get a message indicating success. And then when that's happened, you can expand the databases folder. You may just need to refresh that folder to see the database appear. And there we go, we've got the movies database created. What I'm then going to do is head into a blank Excel workbook. And then from there, we can head straight to the Visual Basic Editor. And then we can insert a new module into the project. We will set a reference to the Microsoft ActiveX Data Objects library, as we're going to be referencing things like connections and record sets and command objects. So to get as much help as possible with the IntelliSense, let's head to Tools, References, and then scroll through the list when the dialog box appears to find Microsoft ActiveX Data Objects. Find the latest version you have, in my case it's 6.1, check the box next to it, and then click OK. Okay, the first subroutine we're going to write is going to return a set of records from a database using a command and a record set object. Let's create a sub called getData using command. We'll then declare three variables using the ActiveX Data Objects library. Let's call one cn as adodb.connection. We'll also have cmd as an adodb.command. And we'll also have rs as adodb.recordset. We'll create a new instance of the connection class first, so we'll say set cn equals new adodb.connection, and then we'll set the connection string property of that connection by saying cn.connectionString equals. Then in some double quotes, we'll specify the provider name first. I'm going to use the name of the provider for my new Microsoft OLEDB provider for SQL. So I'm going to say MS OLEDB SQL. I'll then type in a semicolon, and then I can specify the server name. I'm using a local instance of SQL Server, so I'm going to refer to my local host, or I could of course just shortcut that to a full stop, but let's go for local host for now, followed by a backslash, and then the name of the instance of SQL that I've installed is SQL 2017 Training. Follow that with another semicolon, and then I can specify the database name. So I can say database equals, and then I'll set that to be equal to movies, the database I've just installed. Another semicolon, and then the final parameter just for now, trusted connection equals yes. And I'm setting this to indicate that I'm passing in my Windows credentials to a Windows authenticated SQL Server. So trusted connection equals yes. I'll then just break this across a couple of lines so you can hopefully read the entire string in one screen. And then just to quickly test that this part is working, let's say cn.open followed by cn.close, and then use the F8 key to step through and make sure we've configured the connection string properly. If nothing appears to happen, that's a good sign. It means that we've successfully opened and closed the connection with no problems. The next thing I'd like to do is use the command object to write an SQL query. So let's create a new instance of the command class. setCMD equals new adodb.command. There are several properties of the command we can set here. Let's start by saying cmd.activeConnection equals, and that will be the connection that we've just created and opened. That's equal to cn. We can also say what type of command we're using. We don't necessarily need to do this. SQL Server or ADO will work out what type of command we're using, but if we set the command type, it provides a small optimization, so it should take less time to process. So we'll say cmd.command type equals adcmd text. What we can then do is set the command text property. So I can say, I'll give myself a blank line here, cmd.command text equals, then I'm going to write a select statement. I'll break this across a couple of different lines here. So let's say select, and we're going to get a set of records from the film table in the database. So we need to know a little bit about which column names we have available. If you have SQL Server Management Studio open, you can head back to the movies database, expand the tables folder, expand the film table, and then finally expand the columns folder to see a list of all of the available columns. I'll pick a few columns. Let's start with the title column, followed by a comma, and then the release date, followed by another comma, then the runtime minutes, and another comma. I'll also have Oscar wins just for now, and I think we'll leave it at that just for the time being. I will then type in a space and then close the set of double quotes, and then I'll concatenate the next part on a separate line. The from clause, I need to say which table I'm getting this data from. So I'll say from dbo.film and follow that with another space, and then the part that's going to make this whole video worth it, adding a where clause to allow a user to pass in a value to search for records matching a certain criteria. So I will concatenate another new line, and then I'll add in the where clause, which says where. And for now, what we're going to do is just say where Oscar wins is greater than 0. I'll close the double quotes at that point. What I'd like to do now is execute the command and return its set of results to my Recordset object. So I'm going to say set rs equals cmd.execute. There are a few extra properties we could set for our command execute method. We're not going to bother setting anything just yet, although we'll come back to this a little later on in the video. So for now, we'll just execute the command and return the set of records. What I'd like to do next is pass the results of the record set into a new procedure that will write out the results to a new worksheet, something we've done in several videos recently, so I won't spend too much time on this, but let's just head up to the top of the module and add a new subroutine called write results to sheet. I'll then declare a parameter which will be called something like result set as an adodb.recordset. And then we can do a couple of standard things. Let's declare a variable called ws as a worksheet, and I can set ws to be equal to the result of the worksheets.add method. So that will create a new worksheet in the active workbook. You may remember from previous videos there's a little bug when you try to copy the results from a record set into a worksheet that's just been created. If you don't select that worksheet first, a couple of odd things happen. So I'm going to say ws.select before I then say ws.range a2.copy from record set, followed by a space, and then refer to the result set parameter. We can do a little bit of tidying up. Then we can say things like ws.range A1, and I'll populate range A1 shortly, but I'll say range A1 dot current region dot entire column dot autofit, so we can see all the data we've just copied in. And to make sure that range A1 actually has something in it, what we'll do is we'll write out the field names or the column headings from the record set. So to do that, we've got a couple of choices. This time I'm going to use, let's just loop over the fields collection using a simple for next loop. Let's say dim I as integer. And then after selecting the worksheet, what we will do is say for I equals 0 to resultset.fields.count -1. So we need to make sure the count property, of course, returns the total number of fields in the fields collection, and the collection has an index that's based from 0, so we need to loop up to 1 less than the count of fields, slightly confusingly. Anyway, we can say next I, and then we can say ws.cells, and then use the value 1 to refer to the row number. And then for the column number, we can refer to the value of I plus 1, so that the first column will populate will be column 1, which is the same as column A. We'll say cells.value, and we'll make that equal to resultset, try that again, resultset.fields I.name. Okay, so a fairly standardized way of doing that sort of thing at this point. Let's just quickly call on that method then. After we've executed the command to return the result set, we can say write result to sheet, and we can pass to it a reference to our rs variable. Having done all that, if we simply run the get data using command subroutine now, we ought to end up with a new worksheet, and if we check what's in there, we have a list of Oscar winning films from the film table. What I'd like to do now is try to make this query a little bit more flexible. Currently, of course, I can modify the number 0 here to any other number to return a different set of results, but if I have to do that every single time I want a different set of results, that rapidly becomes tedious. What I'm going to do instead is replace this constant value of 0 with the placeholder symbol for a parameter in ADO, which happens to be a question mark. So if I replace the number 0 with a question mark, that creates a parameterized statement. What I need to do now is each time I execute that statement is map a value to that parameter. And I can do that with the execute method. If I open a set of round brackets, I'll see that there's a parameter called parameters. So if I refer to the parameters parameter and then make it equal to, let's go a bit higher, let's go for the number 5 in this example. If I then close the round brackets at that point and then execute this subroutine again, this time I should see a different set of results coming out. Clearly far fewer results. Not many films have won more than 5 Oscars. But here's my list of films which have. Just in case you know anything about films, there is a deliberate mistake in the database, by the way, to do with Terminator 2. It didn't actually win 6 Oscars, but anyway, it's a deliberate mistake that's in there for demonstration purposes, so I'm going to leave it as it is for now. The important thing is that we've got the ability now to pass a value into the parameter each time we execute the query. Now, of course, this hasn't actually done all that much to help us out at this point. I still have to manually change the value here if I wanted a different set of results. But if we employ some kind of user interface to allow the user to type in a value, suddenly then things get a lot more dynamic and flexible. So let's do something really simple. Let's use a basic input box to allow the user to type in a number. If I declare a new variable, I'm going to declare a variable whose type is a byte. So I'm going to say dim min Oscars as byte. And then I'm going to say min Oscars equals input box, open some round brackets and some double quotes, type in a number between, well, the range of a byte data type is 0 to 255, although the range of Oscar wins in the database is only 0 to 11. So let's indicate that I want 0 to 11 for the user to type in. So if I say 0 to 11, close the double quotes and then close the round brackets. Actually, before I close the round brackets, it might be worthwhile specifying a default value for the input box. If I type in a couple of commas to move on to the default parameter, I should really name the parameters, but I'm just being a little bit lazy at this point. Type in the value of 0 for the default and then close the round brackets and hit enter. Now what I can do is change the hard-coded number 5 in the parameter in the execute method and replace that with a call to the min Oscars, or a reference to the min Oscars variable. So having done that, if I run the subroutine again, I can now type in any number between 0 and 11. Let's go a bit higher this time. Let's go for 7 or more. So if I type in 7 and then click OK, I will now get a new set of results showing films which won more than 7 Oscars. And each time I run the subroutine, I can type in a different number and the results will reflect what I've asked for. Now, of course, whenever you build a user interface, you have to start considering all the potentially silly things your users might do. So with an input box, it can be quite difficult to control what users type in. Technically, an input box always returns a string, and if a user just happened to type in some text and tried to return that to a variable which can only capture a byte, then things will go wrong. We'll get runtime errors. So an input box, although it's possible to control the results, it is a little bit tricky. It requires quite a lot of code to make that work effectively. A user form would be a much better choice. We could develop a user form which allowed the user to type into either a text box or even create some kind of spin button control which allowed the user to increase and decrease the value of Oscar wins they were after. We do have a separate tutorial on creating user forms in VBA which covers all those sorts of ideas, and it's quite an involved process, so I don't want to get into that right now. What might be a simple choice just for this video is to actually use a worksheet or cell on a worksheet for the user to type values into. So what I can do here is if I switch back to the Excel workbook and head to sheet 1, maybe let's change the name of sheet 1 by double clicking on it first, and then let's call this something like query inputs, something along those lines. And then let's have a little header cell in cell A1. We can call this query inputs. And then below that, we can type in the first little heading there, min Oscars or minimum Oscars. I'll just change the column width a little bit. I might merge these top two cells into a single cell, merge and center, do a tiny bit of basic formatting because I can never resist doing this just to make it look a little bit like I've made some sort of effort at least. And then nearly there. And then we can refer to cell B2 or range B2 as our simple query input. So let's just modify the code to take that into account. We've got a query inputs worksheet. If I switch back to the Visual Basic editor, it might also be worthwhile changing the code name of this worksheet to make it easier to reference. So if I select the sheet 1 object in the Project Explorer, I can change its code name here. Let's call it query sheet. Then what I can do is completely forget about the idea of an input box and a reference to that variable. And what I can then do is simply directly reference my query sheet range b2.value. So I could say query sheet.range b2.value. Now, of course, just like with an input box, a user could type in absolutely anything into range b2. However, it's much easier to control this. We could write some simple if statements here before anything else happens in the subroutine to control what a user does. So just to give this one a quick test, if I switch back to my query inputs sheet, if I type in a number, let's go quite high this time, let's go for the number 9, and then I'll create a simple little button on the worksheet so that I can click on this to launch my subroutine. If I head to the Developer tab and then look for the Insert button here, I'll add a basic form controls button. I'll draw one of these somewhere over towards the right hand side. If you like your buttons to line up exactly with the edges of cells, you can hold down the Alt key, the one at the left hand side of the spacebar, and you'll find that your button snaps exactly to the sizes of the cells in which it sits. So I'll release the mouse button first and then release the Alt key, choose my Get Data Using Command subroutine and then click OK. And then I'll edit the text on the button, get results, why not? Sounds nice and simple. Then I can click anywhere else in the worksheet, followed by clicking my Get Results button, and now I'll return any films which have won more than 9 Oscars. Now at the moment it is still possible for the user to type in a value which won't return any results. If I switch back to the Query Inputs page and type in a too large a number, let's say 15, and click the Get Results button, we end up with essentially an empty worksheet. One way we can avoid that is by testing how many results are returned by the record set. If I switch back to the Visual Basic Editor, immediately after executing the command and returning the results to the record set, we could check for a couple of different properties. When you open a record set, the record set contains all of the records, and then at the very beginning of the record set is a marker called BOF, beginning of file, and then at the end of the record set is a marker called EOF, end of file. If the record set doesn't contain any records, then the pointer, the cursor, is sitting on both the BOF and the EOF marker at exactly the same time. And the only reason that could be the case is if there aren't any records in between them. So what we could do is check if rs.bof It's a Boolean property, so you can either test if it's equal to true or just if rs.bof is exactly the equivalent. And rs.eof, then we could just perhaps present a message, say message box, there are no results. There are no results matching these criteria, something like that. I'll just keep it simple, there are no results. And then let's say VB exclamation for the buttons parameter, just to display a different symbol. We can then exit from the subroutine before we call the write results to sheet method so that we don't end up with a blank worksheet. So having done that, if I switch back to Excel now and have a look at the query inputs page, if I click the get results button now, I can see that there are no results. But if I were to type in a value which would return some results, let's go with 7, and then click the get results button, everything still works as normal. So testing for no results is easy enough to achieve, but it doesn't help with every possible problem. For example, if the user tried to type in an invalid data type into this cell. If I typed in a bit of text instead of a number, and then click the get results button, rather than just returning no results, I get a runtime error because I can't convert the string of text, which is referred to as varchar data, that's the data type in SQL, into the data type tinyInt, which is the equivalent of a byte in VBA terms. So I'll click the end button here to stop this from running. We could prevent this from happening in a couple of different ways. Of course, we could write some validation code in the VBA routine. We could write if statements to check if the value in this cell is numeric, and if it is the range between 0 and 11. So if statements would be one simple way to achieve this. But perhaps even more simply, we can just use some basic Excel methods, for instance, the data validation tool. So if I typed in a valid number in the first place, I'm also just going to modify my query a little bit. I've realized that if I'm saying minimum Oscar wins, then I should be checking for films with an Oscar wins value of greater than or equal to the value of the parameter. But if I switch back to Excel now and then head to the data tab in the ribbon and choose the top half of the data validation button, this allows me to specify what values are allowed to be entered into this cell. So what I want to do is allow a whole number with a range between 0 and 11. I just happen to know that 11 is the maximum number of Oscar wins in the database. I can also provide a custom error alert, basically like a custom message box that tells the user what they've done wrong. So for the title, I could say invalid Oscar wins, and then enter an error message telling the user what to do. Type in a number between 0 and 11 so they know exactly what they need to do to fix the problem. And then if I click OK, if I type in an invalid value again and then hit enter or click away from that cell, I get immediately told I must enter a new value by retrying it or cancel what I'm doing. If I cancel, it goes back to its original value. If I type in an invalid value again and click retry, I'm forced to enter a valid value. So let's go for 8 this time, and then click the get results button again, and now everything works as intended. Okay, let's make things a little bit more complicated. Let's create multiple different parameters in the same query. If we switch back to the Visual Basic Editor, let's extend our where clause. So we've asked where the Oscar wins is greater than or equal to question mark. I'd also like to add in and runtime minutes is greater than or equal to question mark, and release date between question mark, and title like question mark. So quite a lot of parameters there. Total count 1, 2, 3, 4, 5 parameters. We've already dealt with the first one, which is the Oscar wins. We'd also like to pass a value to the runtime minutes, which will behave in a very similar way to the Oscar wins. We'll see anything that's greater than or equal to that. Then a release date which falls between 2 specific dates that we pick, and then finally a parameter for the title text that will allow us to pass in wildcard characters to find films whose name contains particular strings. The problem we've got at this point, of course, is that our parameter in the execute method of the command object, as we've written it at the moment, only accepts a single value. What we need to do in order to pass in all of the other values is to create an array. Let's make it easy to fill in the values in the first place. Let's head back to the Excel worksheet And let's type in fact, let's just copy down the min Oscars another 4 rows and then just overtype this with min runtime. And then let's have start date and end date. And then finally, something like title text. Okay. Then let's just fill in some random values without some validation yet. Let's go for 120 for the minimum runtime. Let's go with 1st of the 1st 1980 for the start date. And then a quick way to enter today's date in a cell in Excel is just to press the control and semicolon keys. Control semicolon just types in today's date. For the title text, I can just do something simple like the followed by a percentage sign, which is the wildcard for any string of any characters. So that will find films whose title begins with the word the. Okay, so having done that, what I now need to do is head back to the Visual Basic editor and work out how to reference each of those cells in my execute method. The way to do this is to use VBA's array function. So I'm going to set the parameters parameter to be equal to an array of values. So I can call on the array function, open up some round brackets, and this will return or pass in an array of values in a comma separated list. Let's just try to make this slightly easier on ourselves and split this onto multiple different lines with the space underscore continuation characters. I then know that at the end of this I'll need to close an extra set of parentheses, so let's fill that in now. And then what I can do is start typing in commas followed by a space underscore and break this onto multiple lines. So now what I'm going to do is just copy this line here, query sheet.range b2.value, comma, space underscore, and then just paste that in 1, 2, 3, 4 times. I can then reference cell B3, B4, B5 and B6. The sequence of values that are passed into the parameters parameter is the exact sequence of the question marks in the query string. The last little thing I needed to do here was to take away the space underscore on the last line there. I'm not breaking that onto a separate line, and the comma as well. And then if I enter that, that will accept all the values from the cells in the worksheet. So let's give this one a quick try. If I switch back to the worksheet and I've got these values filled in, so films with, let's just knock down the Oscar wins a little bit. Let's go to 5 Oscar wins lasting at least 120 minutes between these two dates, starting with the word the. If I click the get results button, I end up with just those 4 films matching all those criteria. Now, of course, we could do with adding some data validation to make sure the user fills in valid values, and there are several ways we could do that. But again, we could go back to the query input sheet and we could say stick in a min runtime validation criteria that must be a whole number. So I could go back to data validation for cell B3 and I can make this a whole number with a range of 0 to, let's arbitrarily say 300. The actual maximum runtime in the database is 260 minutes, but 300 should be enough overhead for future results. If you're not sure, you could always stick in a ridiculously large number there, but we'll stick with a simple example just for now. I don't have to set a custom error alert. I can just get a generic error message if I leave the error alert page blank, which I will do in this case. So then I can click OK. And then for the start date and end date, I think I'll validate these to be the same. If I select both cells at the same time, I can choose data validation, and then on the settings page, I can allow a date which has a range of the 1st of January 1900, which is the earliest date value you can enter in an Excel cell. And the end date, I want to be equal to today's date. So I don't want to enter any future dates. So if I type in equals today, open and close some parentheses, that's the function that returns today's date in Excel worksheets. I can then click OK. So if I try to enter a date that is after today's date, so for example, if I type in the 25th of June 2019, that will fail because it's after today's date. So I'll cancel that. If I try to enter a date, well, I can't enter a date and treat it as a date value that's before the 1st of the 1st 1900, so I don't need to test that. For text, we could say that this must be text, but then in some cases, some film titles consist of numbers. So for example, the film 300 is just a number. I mean, technically that could be treated as text, but for text, I'll leave that slightly more free. So maybe worthwhile writing an instruction or two, maybe in the cell next door, or a little instruction in column C to tell the user what they can enter into that cell. So we've seen one way to pass values to parameters in a query string, but there is another technique we can use as well, which requires a little more effort but gives a little more control over the type of parameter and also allows us to reuse it slightly more easily as well. So to make this work, let's switch back to the Visual Basic Editor, and what I'm going to do is take a copy of the getDataUsingCommand subroutine, the one we've just been writing. I'll then head down to the bottom of the module and paste this in, and then give this a new name. Let's call this one getDataUsingCommand and parameter. I know we've already used parameters. I can't think of a better name for it than that. If you can, please feel free to add a new name in the comments. So for now, what we'll do is we will declare a variable which can hold a reference to a parameter object. So adodb.parameter. What we'll then do before we execute our command, we're going to create some parameter objects. So one by one, what we can do is say set PM equals, and then we can say cmd dot create parameter. If I then open some parentheses, there are several things we can specify when we create a parameter. First of all, we can give it a name just to make it slightly easier to reference later. So let's call the first parameter min Oscars. We'll sort of match the labels we added in the worksheet earlier. Then we need to specify the data type of the parameter, and the data types you'll see here aren't quite as familiar to you as the VBA data types might be. If you know SQL Server or SQL at all, then these data types might look a little more familiar. If you're not entirely sure what data types you should be using here, think about the data types in the underlying table that we're passing or testing these criteria against. So if I'm looking where the Oscar wins field is equal to or greater than or equal to something, if I switch back to SQL Server Management Studio at this point and have a look at the Oscar wins column, you'll see that its data type is listed next to that as tiny int. So if I were to look in the list of data types in the VB editor, if I press Control and Spacebar to bring that back, I should find a data type called ADTinyInt in there. There it is. There are a couple of other things I can specify. There's a direction option, which the default is for the parameter to be an input parameter, and that's exactly what I want, so I don't need to specify that. There's a size parameter, which allows me to specify the size. This is only relevant for text, variable length or fixed length strings, and some other types as well, but not for tiny ints. Tiny ints have a fixed length, so you can't change its size. Value, we could assign a value to it here as well. So for example, if I wanted to reference querysheet.rangeb2.value, I can reference that within the create parameter method, but we're actually going to do this in a slightly different way. Let me just name these parameters so I know what I've done here. I'm going to say name : equals, then I'm going to say type : equals, and I've chosen the tiny int type. Then I can close the round brackets. Just on the subject of data types, there are a couple of extra references you might find useful. If I switch back to the Visual Basic Editor just for the moment, if I have a look at, first of all, this page here, using ADO with OLADB driver for SQL Server. This is specifically related to the latest OLADB driver that I mentioned earlier. Just because some data types in the new OLADB driver don't map quite correctly with the ADO data types. So the connection string has an extra parameter available, or a new keyword, called data type compatibility. And there's a little hint here that if you want to make sure that everything matches exactly, set the data type compatibility keyword to 80. So I can just copy and paste this here, data type compatibility equals 80. If I copy that and then head back to the Visual Basic Editor, and then at the end of my connection string, after it says trusted connection equals yes, I can paste in that new keyword, finish that with a semicolon, and that will make sure that I'm matching the data types correctly. If you're not sure what data types to go for, by the way, there's another useful reference you'll find on the W3 Schools website. So this is a bit of a mapping of ADO data types with SQL Server data types. Some of them aren't quite so obvious. So for example, in a moment, we're going to create some parameters that use the date time data type in SQL Server. And the data type for that in ADO is called ADDB timestamp. Likewise, we're going to be referencing a text field, which in SQL Server has a type of nvarchar. And then the ADO data type here is advarwchar, just for a bit of variety, I guess. The W stands for wide, by the way, is a wide string data type. Anyway, those are some references you might find useful when you're writing your own code involving parameters. At this point, let's just continue and see how we can now both assign a value to this parameter and then attach it to the command object. So now that I've created the parameter using the command object, I need to append the parameter object to the parameters collection of the command. It all seems a little bit circular, but this is the way that it works. So in order to make that happen, what we need to do is say cmd.parameters.append, and then we need to pass in a reference to the parameter object that we've just created. What we can then do a little later on is assign a value to that parameter, and the value I want to assign to the parameter is the value of range B2 on my query sheet. So to make that work, what I'll need to do is say cmd dot, and then I need to refer to a parameter that I've appended to it. You can refer to parameters either by their index number, so the parameters are indexed from 0 in ADO, so I can say parameters 0.value. Alternatively, if I've given it a sensible name, like as I have here, I can say parameters min Oscars, and that always makes things a little bit more readable, I think. So I'm going to say command.parameters min Oscars.value equals. Then I'll just copy and paste the query sheet.rangeb2.value, and there we go, there's our first parameter assigned. All we need to do now really is just repeat that process. So let's do a bit of copy pasting to speed things up. If I copy the two lines which create and append the parameters first, and then paste those in, and the next parameter name will be min runtime. Now the data type for this one is different to the min Oscars. If I again look back at my table column definitions in SQL Server Management Studio, I can see that runtime minutes isn't a tiny int, it's only a small int. So I now need to find what the small int type maps to in ADO. If I switch back to my W3 Schools reference table and find the small int data type, there's big int, go down a bit further, there's small int. Oh, this one's nice and easy, it's AD small int. You probably could have worked that one out yourself. Anyway, back here I can change the type from AD tiny int, press Ctrl and space, and look for AD small int. I've then appended the parameter to the command. That needs to happen, and it's done in the same order that we're going to reference the parameters again. So just in the same way we reference or pass values to the parameters in the execute method, we do it in the order we've listed the question marks. We need to append the parameters in the same order here as well. I can then set the value of that parameter. So let's just copy this line here and then paste it in. Alter the name of the parameter to min runtime, and then refer to cell B3. Once again, let's copy and paste the code that creates and appends the parameters. In this case, what I'm going to do, I'll copy it once and then paste it in 3 extra times, separated with spaces, preferably as well. Then I can just alter the names and types fairly quickly. So let's change this next one to start date, and the next one to end date, and the final one to title text, so we know what we're talking about. The data types need to change, so as I mentioned, the date time data type in SQL Server, so release date is date time, that maps to the ADDB timestamp data type. So ADDB timestamp, I'll get the words out eventually, maps to date time. So let's change the data type of the start date to, as I say, I won't bother saying it again, that one, not that one, that one. Timestamp, and I'll copy and paste that to avoid having to find it in the list, and paste that in. And then once again, the data type for the title parameter, nvarchar, and you'll see there's a number in parentheses. So text data types like varchar and nvarchar, etc., can have a size value. So this has a maximum length of 255 characters. So for the text parameter, again, if we choose the correct field type, so nvarchar, as I think I pointed out, says maps to advarwchar. So we can change the data type for the title text parameter to that, advarwchar. And then we can also specify a size for the text parameter. So size : equals 255. All right, so the next thing we can do then is assign values to each of these. So let's just once again copy and then paste a line once, twice, thrice. And then we can just update the names by copying and pasting. Double clicking works wonders here to select a single word. So double click on a word just to highlight the entire word rather than clicking and dragging. Copy and paste with Control-C, Control-V. And then it's just a case of updating the cell references all the way through to cell B6. Okay, finally we can get rid of the list of parameters that we were passing in to the command execute method earlier. So we can just say set rs equals command.execute. We can still test if we return any results or not. Write the results to sheet and then close the connection. So quite a lot more code to make this one work, but provides you with a little bit more control over types in particular for parameters in SQL Server. So let's just give this one a quick test. I want to create a new button, get data using command and parameter. Let's head back to the worksheet. And then let's draw a new button using the developer tab. We'll use the insert tool, head to the form controls button, and then draw one of these on the worksheet, holding down the Alt key as I do that. Pick my second subroutine, get data using command and parameter, and then double click to select it. And I can't think of a better name for this other than get results to, so I will leave it like that. Please feel free to make up a better name if you can think of one. It shouldn't be too much effort. And then with all of these values filled in, let's just click the Get Results To button and make sure that we return the same set of results. Okay, so we've obviously done a lot more work here with the creating and appending of parameters, but I did mention that it gives you a little bit more control, especially when you want to reuse a parameter. So I'm going to take us back to a slightly simpler time when we only had a single parameter in our query. Let's copy this subroutine we've just finished writing, and then we can paste this one in down below at the bottom of the module. And let's call this one something like get data using, let's call it get data reusing parameter, which will make sense when we get to the end of this little section. Okay, I'm going to modify my select statement, particularly the where clause, or specifically the where clause. I'm going to ask for Oscar wins exactly equal to the value of a parameter, and then I'm going to remove all of the other criteria from the query. I'm then going to get rid of all of the parameters apart from the min Oscars parameter. So let's get rid of all of those. And then let's get rid of all of the values that we're assigning to the parameters as well, apart from the min Oscars example. So we can get rid of all that stuff as well. Okay. I'd also like to get rid of the if statement, which checks whether we return any records or not, and then exits from the subroutine. So let's just get rid of that and tidy up a little further. And then what we'll do is write a loop, which loops through the numbers 0 to 11, and each time it processes the loop, passes the value of the loop counter to this parameter. So to make this work, let's declare a new variable. We can say dim I as integer, and then before we pass a value to the parameter for the first time, we can say for I equals 0 to 11. Again, I know the values I want to loop through this time, so I'm keeping things simple just for that reason. And then I'll say command parameters min oscars.value equals I, and then we'll execute the command and return the results to a record set. We'll pass the record set to the write results to sheet method, and then we'll say next I and move on to the next iteration of the loop. When you're doing this, it's worthwhile providing one extra property or setting one extra property of the command object. So before we execute the command for the first time, in fact, let's do this after we've set the command text, we'll say cmd.prepared equals true. Now what this property does is essentially creates an optimized version of the base query, which should provide some performance advantage if you're reusing the same parameter value multiple times in the same procedure. Okay, so let's give this one a quick test by running the entire subroutine, and we ought to end up with quite a few new worksheets, 12 of them altogether, of course, counting 0 as well. And if I have a look back at what we've ended up with, I've got a sheet with the films winning 11 Oscars, and then next to that, the films winning 10 and 9 and 8, and so on and so on and so on, through the sequence from 0 to 11. I think at this point we might need to do a little bit of tidying up. So let's just change my Excel window around a little bit, find the last sheet and then hold down Shift and select the first sheet and then right click on those and hit the delete key. Delete option, then I can click the delete button to get rid of everything except for my query inputs sheet. Might have been nice to label the worksheets as we went along, but that's a fairly trivial thing to do, so you could always add that extra bit of code into your write results to sheet method if you like. We could make this a little bit more interesting and complicated by getting the list of numbers we want to process from data in the database. So let's say, for example, I wanted to process my list of genres in the genre table of my database. If I just collapse the film table for a moment and then have a look at the genre table, it's only got 2 columns in it. If I right click on that table and choose select top 1000 rows, that will write a very basic query for me to select the top 1000. There aren't 1000 genres, by the way. There are only about 24 altogether. So what I might like to do is loop through that set of records, and for each number in the genre ID, I might like to select items from the film table where the film's genre ID is equal to that. So the way data is stored in this database, you may be familiar with relational database concepts. In the film table, rather than storing the name of the genre, we store the ID number of the genre. If I select the top 1000 films, if I look in the genre ID column, I can see that Jurassic Park is listed with a genre ID of number 8. And if I have a look back at my list of genres and look for the number 8 in there, that indicates that Jurassic Park is listed as an adventure film. So if I wanted to list all the westerns on one page, all the dramas on another page, all the science fiction films on another page, etc., what I could do is create a record set that loads that table of genres into memory. Then I could loop through that record set, and for each item in there I could read the ID and then select all the films with that genre ID and then write out the genre name as the worksheet name. I think I'll have one small problem with this. If I try to create a worksheet called history, I'll get an error. So history is a reserved word in terms of worksheet names in Excel. So we can alter the history name to something else, or just omit that one altogether. We could omit unlucky number 13 if we like. Anyway, let's have a go at making this work. If we switch back to the Visual Basic Editor, let's make a copy of our get data reusing parameter subroutine. And then we can paste this in down at the bottom of the module, and we'll give this one a different name. Let's call this one get data or get films for each genre. Why not? Let's make this a little more descriptive. Get films for each genre. First of all, let's deal with loading the genres into a new record set object. Let's declare a second record set variable. Let's call this one rsgenres as adodb.recordset. We can then create and populate that record set after we've opened up the connection using the execute method of the connection object. So let's say set rsgenres equals cn.execute. Then we can open up some parentheses and some double quotes and write out a select statement to populate the record set. Let's say select genre ID, comma, genre from dbo.genre. I'll spell that properly. And I'm also going to add in an order by clause. I'm going to say order by genre DESC, so descending order. So the record set will be populated with the genre names in descending order, but the worksheets, when they're finally created, will be alphabetically listed from left to right, which is what I want. So there we go, a quick shortcut way of populating a record set using the execute method of the connection object. It creates a record set with a forward only cursor, which means we can pass forwards through the record set once only, which is what we want to do. And it also returns a record set with a read-only lock type. And as we don't need to modify the genres record set, that's perfect for us as well. Okay, now let's modify the select statement so that we're not looking for films where the Oscar wins is equal to the value of the parameter. We're interested in where the genre ID column is equal to the value of the parameter. Just so we can see that we are definitely getting what we expect to get, let's include the genre ID field in the output columns. So in the select list, we can include the genre ID field from there as well. Now let's continue scrolling down a little bit. Let's head to the create parameter method. So here we're creating a parameter called min Oscars, which doesn't seem particularly sensible to name it that anymore. So let's change its name. Let's just call it genre ID. That will be fine. We can give the parameter the same name as the column, although it's a little confusing at this point. And we should probably rename that well, we should definitely rename that when we reference the parameter in the parameters collection later. So let's do that now so that we don't forget. We can also modify the type. We might need to modify the type. So let's just go away and check what the type of the genre ID field is in the database. It's set to an int rather than a tiny int. So let's change the data type from AD tiny int to AD integer. Then we can deal with how we construct this loop. So rather than looping through the numbers 0 to 11, I want to loop through the set of records loaded into the RS genres record set. We mentioned earlier on the use of the EOF or end of file marker to test whether your cursor is on the end of file marker. That will happen if you load a record set with no records in it. If you load a record set which does contain records, the cursor will be pointing at the first record, and we can tell the cursor to move to the next record until it reaches the end of file marker. So to configure that loop, we'll say do until rs genres .eof. We can then fix this loop or continue this loop by using the loop keyword rather than next. And to make sure that we do actually reach the end of file marker, we do need to ensure that we move to the next record in the genres record set. So rs genres.move next. Okay, not too far to go now. So we're writing the results to a worksheet. Currently our worksheets will all have their default names. I want to make sure that each worksheet has a name of the genre, but before I do that I also need to make sure that I pass the correct value to the genre ID parameter. So rather than passing the value of I, what I want to do is set the value of that parameter to be equal to the value of the genre ID field in the RS genres record set. So RS genres, open some round brackets and some double quotes, and then refer to the genre ID field, and then refer to its value property. And then I'd like to pass in the value of the genre name field or the genre field to the write results to sheet method. But before I can do that, I'll actually need to declare a parameter that allows me to do so. So let's head back up to the very, very top of the module. And let's declare, I don't want to mess up all of the previous calls I've made to write results to sheet. So what I'm going to do is declare an optional parameter called, let's call it sheet name as string. The parameter will have a default value of an empty string anyway, but we can always explicitly set a default value for the parameter. And then after we've selected the worksheet, having created it of course, we could assign the sheet name we've passed in to the name of the worksheet. We should check a couple of things though first. First of all, we should check that we haven't passed in the word history, or if we have, so if sheet name equals history, then we want to make sure that the ws.name is equal to historical. History is a reserved name in worksheet terms, as I mentioned earlier. Otherwise, if it's not history, but as long as the sheet name is not equal to an empty string, then the ws.name can be equal to the sheet name. And then otherwise, well, we don't need to do anything. Otherwise, it can just stay with its default name, sheet 1, sheet 2, etc. Now I can pass in the name of the value of the genre field into that parameter. So if I head back down to the very bottom of the module, type in a comma, and then pass in the value of the genre name parameter, or the genre field, I should say. So RS genres, open some round brackets and some double quotes. Genre, I've said that word so many times it has now ceased to have any meaning, and then refer to the value property of that. Phew, okay, so that looks pretty good to me. I think we're pretty much there. So at this point, let's just give the whole thing a quick test by running the subroutine, and we ought to end up with lots and lots of worksheets. Look at that, beautiful. So if I head back to the worksheet or the workbook at this point, I've got my films listed in alphabetic order. So I've got my sheets listed alphabetically. So I've got action first. They all have a genre ID of 4. And if I just quickly check back at my list of genres in SQL Server, action is indeed genre ID number 4. And adventure, as we saw earlier, is number 8, and so on and so on and so on. So we have all of the films separated out by genre using a couple of different record sets. That will work pretty beautifully, I thought. History now is called historical. There we go, there's the history films. Okay, so we've seen a few different techniques there for passing values to parameters of queries, which gives you a lot more flexibility in terms of what you can retrieve from a database. Hope you found some of those techniques useful, and maybe you'll be able to employ those in some of your own systems in the real world. Thanks for watching. See you next time.